This video is for those of you who want to learn the application of calculus in graphs. So let us go ahead and begin. Now, to determine whether or not the function is decreasing, you simply gonna check the first derivative. If the first derivative is greater than 0, then that means the function is increasing. And also, if the first derivative is smaller than 0, then that means the function is decreasing. So if first derivative is exactly equal to 0, we cannot make any conclusion about whether or not the function is decreasing or increasing. Instead, we're gonna get a point called stationary point. Sometimes this point is called stationary point. Typically, stationary point is called a stationary point is called a turning point in calculus. So if the function is increasing at the left of the stationary point and decreasing at the right of the stationary point, then that stationary point will be called local maximum. It's gonna be local maximum. And if the function is decreasing on the left of the stationary point and increasing on the right of the stationary point, then that stationary point will be called local minimum. So let us put this information on practice. Let us do some practice problems based on whether or not the function is increasing or decreasing. Let us go ahead and do some practice problems. Number 1. Given f of x is equal to x squared plus 2x minus 2, determine the coordinates of the stationary point. Now, to determine the coordinates, okay, let me check something. Okay, everything is fine. Okay, to determine the coordinates of the stationary point, we first need to find the first derivative. So the first derivative of this function is gonna be 2x plus 2. If you differentiate this function, you're gonna get 2x plus 2. And if first derivative is equal to 0, we're gonna get the x coordinates of the stationary point. So it's gonna be 2x plus 2 is equal to 0. And if you transpose 2 to the other side of the equation, you're gonna get 2x is equal to negative 2. And we need to divide both sides by 2 so that we can isolate x from 2. So we're gonna get x is equal to negative 2 divided by 2, you're gonna get negative 1. And this is our x coordinates of the stationary point. For the y coordinates of the stationary point, we're gonna substitute x into f into the original equation f. So it's gonna be it's gonna be f of negative 1, it's going to be 2, so it's going to be negative 1 squared plus 2 into negative 1 minus 2. So you're gonna get, let me punch this on a calculator, squared plus 2 into negative 1 minus 2. So you're gonna get negative 3. Therefore, our coordinates for stationary point, it's going to be negative 1 paired with negative 3. This is our coordinates for the stationary point. On part B, determine where f of x is increasing or decreasing. So to determine where the graph is increasing or decreasing, first derivative, we're gonna apply the first derivative. So this is called the first derivative test. So I also erased my first derivative, but I'm also going to differentiate once again. So first derivative is equal to 2x plus 2. Okay, this is how you're gonna do it. So you're gonna check from the left of the x coordinates of the stationary point whether or not the first derivative is positive or negative. So the values that are from left from these x coordinates of the stationary point, it's -2, -3. Can substitute any value on the first derivative. So first I'm gonna substitute -2 on my first derivative. So it's gonna be 2 into -2. 2 into -2, I'm gonna get you are going to get -4. -4 plus 2, you're gonna get -2. So on our left of the stationary point, the derivative will be negative. Then that means the function is decreasing. And on right of the derivative, you can substitute 0. If you put 0 on x, this expression will cancel out and you're gonna get +2. Then that means on right of the stationary point, the function is increasing. So therefore f is increasing. So let me just do simple thing. Let me just do simple thing. So I'm just doing simple thing. F is increasing at x must be greater than -1, and f is decreasing at x must be smaller than -1. So the function is decreasing at the values where x is smaller than -1. So the function will be decreasing, and also the function will be increasing at the values that are going to be greater than 1. So that's how you determine where the function is increasing or decreasing. Let us try another question. Number 2, given f of x is equal to 2x cubed plus 3x squared minus 12x minus 9. Determine the coordinates of the stationary point. To determine the coordinates of the stationary point, we need to first set up the first derivative to be equal to 0. Our first derivative is going to be 3 times 2, you're going to get 6x squared. 3 times 2, you're going to get plus 6x minus 12. This is our first derivative. Now, we need to divide this equation by 6. Then we're going to get x squared. 6x divided by 6, we're going to get x. And -12 divided by 6, we're going to get -2 is equal to 0. And we need to open 2 brackets. This is a quadratic equation. Now, to solve a quadratic equation, we need to find two factors of 2 that if we multiply them, they're going to give us -2, and if we add them, we're going to get a middle term of 1. So it's going to be +2 and -1. We could set up this bracket to be equal to 0, or this bracket could be equal to 0. So let me erase the top part. Let me just erase the top part of the okay. So you're gonna get x. So you're gonna get x is equal to -2, or x is equal to 0. So Ox is equal to positive 1. These are the x coordinates of the turning point. For the y coordinates that gonna correspond with this x coordinates, we're gonna substitute these x values into the original equation. So if you substitute -2 into the original function, we're gonna get this value. Let me punch this on my calculator. Squared minus 12 into -2 minus 9. So we're gonna get 11, and f of 1 gonna get, let me punch this on my calculator, 2 into 1 so you're gonna get -16. These are the x coordinates of these are the coordinates of the turning point. Just -2 paired with 11 and 1 paired with -16. These are the stationary point. So we need to determine which part of the graph is increasing or decreasing. So let me erase some other stuffs. And so we're gonna need this part of the derivative. So it's gonna be, so let me just write this part here. X plus 2 into x minus 1 is equal to 0. And also erase here. So, okay, so to determine where the graph is increasing or decreasing, on part B, so it's gonna be, you're gonna plug in the x coordinates of the turning point on our number line, and then we're gonna evaluate values that are smaller than -2, and the values that are between -2 and 1, and also the values that are going to be greater than 1. So if you plug in any value that is lesser than -2 on our simplified version of our second derivative, which is this one, so let us try -3 just for control. Let us try -3. So it's gonna be -3 plus 2 into -3 minus 1. So we're gonna get positive value. Then that means our function is increasing on values that are going to be smaller than -2. Let us try to plug in any value that is between -2 and 1. So the simplest value is, it could be 0 or -1. So let me just plug in 0. So if you plug in 0 on 0 plus 2 and 0 minus 1, you're gonna get negative value. Then that means our function is decreasing between -2 and 1. So if we plug in any value that is greater than 1, so you're gonna get positive value. Then that means the function is increasing. Therefore, f is increasing, let me make a space here. So therefore, f is increasing to any values that are going to be smaller than -2 or any values that are going to be greater than 1. And f is decreasing between -2 and 1. So f of x is decreasing between -2 and 1. So on our last question, we need to determine the nature of our stationary points. We have two stationary points. It's -2 period 1 and 1 period -16. So since on the stationary point of -2 period 1, the graph is increasing on left and decreasing on right, then that means the nature of the stationary point is local maximum. And the nature of the stationary point is going to be local minimum. So that's how you determine whether or not the function is increasing or decreasing. Let us try this one. Feel free to pause the video and try this one. So on number 3, given f of x is equal to x squared minus 4x plus 6, determine the coordinates of the stationary point. So we need to set up the first derivative to be equal to 0, and our first derivative is going to be 2x minus 4 is equal to 0, and we need to solve for x. So x is going to be 2x is equal to positive 4. If you transpose -4 to the other side of the equation, you're gonna get the positive value, and we need to divide both sides by 2. 2 and 2, they will cancel out, and you're gonna be left with x. 4 divided by 2, we're gonna get 2. Now substitute x into f. So if you substitute 2 in this equation, you're gonna get the y coordinates of, let me substitute 2 in this equation. So it's going to be 2 squared minus 4 into 2 plus 6. So our corresponding y coordinate is going to be 2. Therefore, our stationary point, so it's going to be 2 period 2. Simply 2 period 2. Now we need to determine at which part of the graph is increasing or decreasing. So let me make a space. I'm not going to erase this first derivative because it is the one that I'm going to test with. So we're going to take our x coordinates of the turning point, and then if we substitute any value that is lesser than 2 to our first derivative, so we're gonna get, it could be 1, it could be any value that is lesser than 2. So let us substitute 1 on our first derivative. So we're gonna get the negative value. Then that means our function is decreasing. Then if you substitute any value that is greater than 2, the first derivative is going to be positive. You only substitute on the first derivative, not on the original function. So original function doesn't test whether or not the function is increasing or decreasing. So it's better to substitute on the first derivative so that we could get a correct answer. So now f is increasing at x must be greater than 2, and let me erase here. And f is decreasing at x must be smaller than 2. These are the parts where the function is decreasing or increasing. And the nature of the stationary point, to period 2 is a local minimum. It's a local minimum because the function is decreasing at left and increasing at right. So our stationary point going to be a local minimum. So let us try another one. f of x is equals to x cubed minus 9x squared minus 27. Then determine the coordinates of the stationary point. So to determine the coordinates of the stationary point, we need to set up the first derivative to be equal to 0. And our first derivative is going to be 3x squared minus 2 times 9. You're going to get 18x minus, okay, if you differentiate negative 27, you're going to get 0. Then let us divide by 3 and also take out the common factor of x in this equation. So we're going to be left with x minus 18 divided by 3. We're going to get 6 is equal to 0. And x is going to be 0, or x is going to be x minus 6 is equal to 0. If you transpose negative 6 to the other side of the equation, you're going to get x is equal to positive 6. These are the x coordinates of the stationary point. Now, we need to find the y coordinates of the stationary point by substituting these x coordinates of the stationary point to our original function. And we're gonna get the stationary point. So our first stationary point is going to be 0 paired with, if you substitute 0 in this expression, gonna get negative 27. And another stationary point, if you substitute 6 to this function, you're gonna get let me punch this on the calculator. 6 squared minus 27. So you're gonna get the stationary point. So it's 6 paired with negative 135. So it's gonna be 6 paired with negative 135. These are the stationary points. Now let me rewrite our simplified version of our first derivative and also erase everything here. Now, our x coordinates of the stationary point is 0 and 6. We need to evaluate what's going to happen to what's going on values that are smaller than 0 and also the values that are between 0 and 6, and also the values that are going to be greater than 6. So if you substitute 0 here, you're gonna get 0, but so that thing, we're not gonna make any conclusion if you substitute 0 and 6. in this version. So we need to substitute any value that is going to be smaller than 0 in this version. So if you substitute -1, anything multiplied, so if you substitute -1, so it's going to be negative into -1 minus 6. You're gonna get a positive value. So you're gonna get a positive value. Then that means our function is increasing on our left of the stationary point, and we need to substitute any value that is between 0 and 6 on our first derivative. So it's going to be, you can substitute any value. So I'm going to choose 2. So it's going to be 2 into 2 minus 6. So you're gonna get a negative value. Then that means our function is decreasing here, and here it's going to increase. So f, let me write here, f is increasing at, so our f is increasing at x smaller than 0 or x is greater than 6. And also the original function f of x is decreasing at the values that are between 0 and 6. The nature of the stationary point. So since f is increasing at left of the stationary point and decreasing at right of the stationary point, then that means this stationary point is a local maximum. Then this stationary point 0 period negative 27 is going to be a local maximum, and this stationary point is going to be a local minimum because the function is decreasing at the left of the stationary point and also increasing at the right of the stationary point. That's how you apply the first derivative. First derivative test whether or not the function is increasing or decreasing. So hopefully maybe you've enjoyed this lesson. So if you like this video, I'll create more content for you. So smash that button, smash that subscribe button so that I could create more content for you. And thanks again for watching this video. Have a nice day.